Okay, so these are the video solutions for the second assessment task in 2023 for Mathematics Advanced. Starting at question 6, part B, and there's short answer questions. So the first question that we look at here, part A, is wanting us to differentiate y is equal to e to the x over x plus 1. What you'll notice is x is happening in two different places. So there's two different functions, one on the top, one on the bottom. I'm going to let the u be equal to my top line, v be equal to my bottom line, and I'm going to use the quotient rule. What you need to do, and a lot of you are not doing this, is actually popping in what u and v is so that you've got it there. You may get marks for that if you make a mistake. So my top line is u, which is e to the x. When I differentiate that, I get u dash, or du dx, which is also e to the x. My bottom line is v, which I've let equal to x plus 1. When I differentiate that, I've written it as v dash, I get 1. If you set it up like this and pop your cross arrows in, you end up getting the right things together for the formula. Now, the formula is straight off your formula sheet. Now, I always think of it like this, but your formula sheet writes it like this. V du dx minus u dv dx all over v squared. This time most people did okay at copying that down, but a lot of people did not use the quotient rule at all. So there's no other way to get around this question by the quotient rule. All we're doing is substituting straight into that formula then. I'll end up with my y dash is equal to e to the x times x plus 1 minus e to the x all over x plus 1. Don't forget that squared. I'm going to expand this bracket out, so I end up with x e to the x plus e to the x, and I've got that minus e to the x tacked on the end there. These guys cancel out, so I'm left with x e to the x all over x plus 1 squared, and that is my answer for that question, and that was worth 2 marks. Part B wanted us to find any stationary points. So what you needed to remember that stationary points occur when the first derivative is equal to 0. So y dash is equal to 0, and we found that up above. So here's my y dash from the part A. I set that equal to 0. What we end up getting when we multiply both sides by x plus 1 squared is it cancels out on this side. It goes to 0 on this side, so our equation becomes x e to the x is equal to 0. Now, we need to set those parts to 0. So I've got x is equal to 0, this part here, and e to the x I'm setting to 0, but e to the x can't equal to 0 if you think of what the graph of e to the x looks like. So I've got x is equal to 0. Now I need to find my corresponding y point, because my question asks me to find not just the x value, but the actual stationary points, and a point is an x and y value. So if I pop that x value into my y, which I had way up in part 1, there it is up here. I'm going to get e to the 0 on 0 plus 1. E to the 0 is 1, 0 plus 1 is 1, so I get 1, so my stationary point is 0, 1. I'd like you to try and pop the point at the bottom, if you can, instead of just leaving the point sitting there. Okay, let's look at question 7. Question 7 wanted you to differentiate y is equal to x e to the 3x. What you'll see is x is occurring here, x is occurring here. It's occurring in two spots. There's two functions involving x that are popped together. You want to use the product rule because they're times together. I'm going to let my first part, x, be equal to my u. My second part, e to the 3x, be equal to my v. Then I need to differentiate both of these. So my u dash is 1. My v dash is 3e to the 3x. What you needed to do was then go to the H2C formula sheet and copy down the product rule. I write it like this. The H2C formula sheet is slightly different. Oops, so I'll just fix that up. The H2C formula sheet is writing it as v du dx, which is exactly the same, plus u dv dx. Okay, so you don't get a mark for copying that down because that's given to you, but you need to substitute them in. So if you write it again like this, I can cross my values like this. V du dx, so e to the 3x, plus my u and my dv dx here is my 3x e to the 3x. Now, I'm not going to leave it like that. I'm going to factorize it. I always want to look to see, can I go one step further with this? And I can pull out an e to the 3x, which is 1 plus 3x. This is correct, but I'd like to see it like this as well, because if we were looking at stationary points, we could not do that in this form. We need to look at it in this form here. And if we have a look at the next question, it's saying, hence, use the reverse chain rule. Okay, so let's have a look at what we've got. Okay. So we want to integrate between 0 and 2 e to the 3x times 3 plus 9x. Now what I did here was I factorized this bracket and pulled out a 3 and just popped it out the front there. When I do that, I get my e to the 3x is still there, but my 3 I've pulled out, and in my brackets I've now got 1 plus 3x. So that's what I want to integrate. Now what we know from the question above, if we think about what we had, I've differentiated this function to get this. So if I integrate this one, my answer is what I had at the start. So if I integrate what I had in question part A, there's my solution, and it looks very similar to what I had here. It is 1/3 the size. So what I need to do is multiply this by 3 to get my answer here. Multiply my answer by 3. So I get 3x e to the 3x. And I'm going to look at that between 2 and 0. When I sub that in, I end up with 6e to the 6. And that was worth 2 marks. So the reverse chain rules are quite easy. Make sure you practice lots of those. Now we're going to have a look at question 8. Okay. Question 8 says, if the first derivative, f dash of x, is equal to 1 plus 2e to the minus x, and we're given that f of 0 is 1, we want to find our function f of x. Okay, so we're going to find f of x by integrating the f dash of x, and I'll pop that in there with respect to x. So when I integrate f dash of x here, I'm going to get 1 when I integrate it becomes x. 2e to the minus x will become minus 2e to the minus x, and I need to add my plus c. A lot of people are not adding plus c. You didn't add plus c, it's not going to work for you very well in this case. Now, I'm going to substitute in f of 0. I'll just fix that up there. So this is my function. When I pop 0 in for x, I get 0 minus 2e to the 0 plus c, and that is equal to 1, because that was given to us up here. When I rearrange that, I'm going to end up with minus 2 plus c is 1, so c is equal to 3. That then goes into my function, and my 3 replaces my c up here, and so this is my function, x minus 2e to the minus x plus 3. Okay, pretty stock standard question, that one. Now, second part says, hence find f of 1. You needed to find f of x in order to find f of 1, so all I've done is popped 1 in where there is an x, and that's given me my answer. So 1 minus 2e to the minus 1 plus 3. Please don't pop it in your calculator. I want to leave it as an exact form. 3 plus 1 is 4. Minus 2e to the minus 1 I've just written as minus 2 over e. But you could have written it as 2e to the minus 1 as well. And that's your solution there. Okay. Question 9. Let's have a look at this one. Okay, so question 9 says, use 2 applications of the trapezoidal rule to find an approximate value between 0 and 2 of the square root of 1 plus x squared with respect to x. And we want to answer to 2 decimal places. So there's a bit of information in there. When we're looking at 2 applications of the trapezoidal rule, if this was our graph, for instance, and here's our value of 0 for x, and here's our value of 2, 2 applications of the trapezoidal rule means I want to have 2 trapeziums. So I would like to have n is equal to 2. I've got 2 sub-intervals, and I've got 3 function values. So I'm going to write that in there. 2 sub-intervals, 3 function values. So I've got n is 2, and I need to have a number in the middle, which is going to be 1, because that's going to evenly space it between 0 and 1 and 1 and 2. This was a HSC question from last year's HSC, so a really good question to get really good at. We're looking at trapezoidal. So trapezoidal rule is on your HSC formula sheet, so you need to go and copy that one down now. Okay, so trapezoidal rule gives us b minus a over 2n. It wants us to do function a plus function b plus 2 times the functions that are in between. So that's going to be the function of 1. So I might just call that function c, for example. So what I want to have, is my b minus a. They're my upper and lower limits. So I've got 2 minus 0, because they're my b's and my a's, all over, it was 2n on the bottom, sorry. 2 times n, so 2 times 2, which is 4. F of 0 plus f of 2 plus 2 times f of 1. Okay, so let's fix that up. 2 over 4 is a half. F of 0, what's that going to be? That's going to be 1 plus 0 squared, square root is 1. Pop my 2 in. 1 plus 2 squared is 4, plus 1 is 5, plus the square root of 5, plus 2 times f of 1. 1 squared is 1, plus 1 is 2, plus root 2. Okay, this question does not want us to put this into exact value. It wants it in terms of 2 decimal places. Okay, so all you need to do is pop this now into your calculator, and what you're going to end up with is the value 3.03. And that is our approximation using trapezoidal to this function here. Okay, let's scroll down and have a look at question 10. Question 10 says the parabola y equals x cubed minus 7x, which we know is this cubic line here, meets the parabola y equals 2x, which is our straight line, at the points 0, 0 and A as shown in the diagram. Okay, this one was one that was given to you as the question aided task, and it wants us to find the coordinates of point A. Some of you may note that that was given to you for home to study, but I want you to show me what those coordinates are in this case. So we're looking at where those two graphs meet. So you're going to be looking at basically a simultaneous equation. So we want to find where x cubed minus 7x is equal to 2x. So algebraically, I've written that down there. X cubed minus 7x equals 2x. Let's bring the 2x over to the other side. So we get x cubed minus 7x minus 2x, which simplifies to x cubed minus 9x. Now, don't panic that it's a cubic because there is an x in each side, so we can factorize out that x. So we'll end up with a quadratic. X squared minus 9 is equal to 0. And what you will see that is a difference of 2 squares. So you could do it as that, or you could alternatively do that another way. So you'll end up with x minus 3, x plus 3 is 0. Setting each part to 0, we get x is 0 and x is plus or minus 3. Now, we know from our graph that we don't want the point x is 0, and this would be the point down here somewhere that it cut where x is minus 3. We want the x value of 3. So you needed to notice that that was the one that we wanted. And then I needed to find my corresponding y value because the question asks us to find the coordinates of A, not just the x value. So I want to find y. If I substitute that into either one of those two equations, when x is 3, I would pick this line here. Y is 2 times 3, which is 6. So the point is 3, 6 that I want. Okay, now we want to find the area enclosed by the parabola and the line. So basically the shaded region. So if you remember what we did back in class, if we're looking at the area between two graphs within a particular set of x values or a domain, we have a look within that domain. And so in this case, that is between x is 0 and x is 3. And we want to have a look at which graph, or if there is a graph that sits above the other graph the whole way through that range of, that domain of values. So between 0 and 3, this curve, y equals 2x, is always above the curve, x cubed minus 7x. So I want to integrate this line, take away the bottom line. And that's what I'm going to pop under my integral down here. So let's go back down here. So under my integral, between those two values, I've got my top line, 2x, minus my bottom line. It's minus the whole bottom line. So that minus needs to be carried through to both of those. If I do that, this is what I end up with. So 2x plus 9x minus x cubed. So there's my integral. I'm going to integrate between 3 and 0. Let's integrate that. Adding 1 to the power, dividing by the power, I get 9x squared on 2. Adding 1 to the power, dividing by the power, x to the 4th on 4, between 3 and 0. Let's pop 3 in. This is what we end up with. 9 times 3 squared over 2, minus 3 to the 4 on 4. We'll work that out. Minus, when I pop 0 in there, we have basically 0. So what we're going to end up with is 3 squared is 9. 9 times 9 is 81 over 2. Minus 3 to the 4 is 81 over 4. Either work that out using paper or on your calculator. It will give you 81 over 4. And I wanted that in those units. I don't want them using, I want you to use your I don't want decimal places. It's area in this case, so we want to have units squared on there. And that is the end of that video.